This video on First Updates Now is made possible by viewers like you and also the following sponsors. If you want to continue enjoying the excitement of robotics, come check out what's going on at Kettering University, including their Combat BattleBots team and First Center. Turn your robotics experience into a professional career. Be sure to apply to Kettering beginning in August of 2022. Go to kettering.edu/apply to learn more. Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support FIRST teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today.
Hello, welcome to our 2022 Valor CAD Challenge Award Ceremony, presented by First Updates Now. We have 15 incredible robot submissions to show off and play our new game, Arcade Artillery. I'm Alejandro Diaz, your host and lead organizer of this year's Valor CAD Challenge from FRC 6800. Before we get into the game and submissions, let's introduce our judges for this evening who have been working hard to critique each one of these incredible designs. First off, we have Sebastian Ochoa from FTC 9527. And also we have on our panel today from FRC 6800 Valor is Luke Ballingy. I would also like to thank Milan Patel and Kian Yakub from FRC 6800 and FRC 2714 who are judges for our panel but aren't going to be here, unfortunately. So before we get into this, let's start with explaining a bit about the game. This year's Valor CAD Challenge, we decided to provide teams with a new and exciting challenge to the game, Arcade Artillery. The game features a low-traction PTFE flooring in similar style to the 2009 FRC game Lunacy. However, this surface has a far lower coefficient of friction, and teams must have to design around this, as it will make roller-based drivetrains like Mecanum and Omni-wheel drives obsolete. The field contains 72 red and 72 blue ski balls, which are 3-inch diameter hard plastic spheres that teams must collect and shoot to earn points. The game features a ski ramp where teams can shoot up to 3 balls at a time and earn points for Alliance and work towards earning ranking points. In the endgame period, teams are able to earn points and gain RP through climbing the HAB structure, which features a 13-inch high jackpot level, a 1.75-inch mid-level, as well as a 12-inch underpass that teams can utilize during the match. With 15 submissions, all were extremely fantastic and very competitive towards one another. It was really difficult to choose between our rankings, but we created a very helpful and insightful rubric for teams to follow that has been made public during this design process. This is split into 5 major categories. Our press release, worth 25 points, the general robot design, worth 40 points, the detail and engineering excellence of the robot, worth 40 points as well, and lastly, innovation and aesthetic as the last major category for 30 points, and we have renders for 5 points. With that being said, we're now ready to show off all the amazing submissions. We're going to kick it off with our 15th ranked team, team number 73 Donut, made by Matthew from FRC 6328. This robot was really cool to see, but we really love the design of the donut wraparound to hold 3 balls. However, we didn't get a clear execution with everything. We would have liked to see a little more attention to electronic detail, but it's very clear what the design was, and we like the innovative hoe design that drops down to scoop up balls. This hoe design was something that we didn't see from any other robots, and made a good tactic towards reaching a little extra further into that paywall area to reach. All right, and moving on, we have our number 14th ranked team, Team 3, Triple Tree, designed by Carlos.
Okay, so what we liked about Triple Tree was its cool extending surgical tubing intake, similar in style to many Rover Ruckus intakes, as well as a vertical tower with a flywheel to shoot into all of the goals on the ski ball ramp, which we felt would have been able to hold all 3 balls and to be able to score effectively into goals. However, the robot, we would have liked to see some more electronic detail, similarly to the previous robot, but the drivetrain and extending intake overall were very well designed.
All right, moving on. We have our 13th ranked team, Team 2, Pink Void, designed by Kevin and Radish from FTC 1830 Leviathan.
Yeah, so with this team, some of the things that we really liked were that they had a really good press release and it had a lot of nice aesthetically pleasing graphics. And they sort of like outlined their robot very well. Another thing was that their drivetrain utilized this tread that looked like it would have gripped the ground very well. And so something that we would have liked to see improved on was their intake. The intake didn't have like a large scope, and so it could only pick up balls from a small area. And also, the ball path could have been made a little bit more clear and a lot easier to allow for faster cycles. But overall, we really liked their press release, and their outtake with an adjustable hood angle was something that we liked.
All right, moving on to our 12th ranked team, Team 0000 Robot, designed by Manav from FTC 15146. All right, this robot, we really liked all the active states we got with the renders, and we thought that the wide intake would provide for a great competitive advantage, being able to easily find 3 balls and pick them up with ease. We would have liked to see a little more detail with that hopper mechanism, as we felt that it would cause a lot of jamming points as the 3 balls travel from the intake into the shooter area. But we did like the inclusion of a turret mechanism, and we thought it was pretty well structured with an adjustable hood as well. And moving on for that, we have our 11th ranked team, Team 3374, Mr. Roboto, designed by Parker, June, and Gabe from FRC 3374.
We really liked this robot as it had the same extending intake, allowing the robot to not have to cross the terrain, as well as a differential swerve drive, which would have given a competitive advantage in the actual game, as well as allowing for holonomic motion with higher amounts of grip than a Mecanum drivetrain. One really unique thing about this robot, however, was that their turret and shooter was also on the extension, which would have allowed for faster cycle times as they could just extend their turret towards the goal to shoot instead of having to drive all the way over. Additionally, their turret does appear to have a hood on it, which will allow for more fine tuning in their actual shooting position.
Yeah, we really love the differential swerve drive that this team included, and they also made use of really wide Gobilda wheels, which we thought would add a little more traction, but we would have liked to see a little more press release insight with this team. And before we get into our top 10 teams, let's take a moment to bring on our producer Tyler to start a giveaway from Gobilda and talk about one of Fun's sponsors.
Hey, thanks a lot, Alex. Yeah, our first giveaway is going to be, of course, from Gobilda. It's going to be a Dark Matter t-shirt that they're giving away. Pretty awesome. By the way, if you're doing this, please shoot me, Tyler, a message with your mailing address as well as shirt size with that as well, too. If you're interested in winning this, just type in Dark Matter, 2 words, type that in the chat. That's your keyword to get in. And as we do that, we're going to hear about one of our sponsors, which is Kettering University, and a little bit more how you can graduate debt-free at Kettering.
When I was considering where to go to college, one of the biggest things for me was figuring out how I was going to be able to pay for college. And it wasn't really until I came to Kettering to one of the Dog Days of Summer events that I figured out how I was going to be able to do that. And it was actually because of this senior chemical engineering student. She was getting ready to graduate and she had told me about all of her phenomenal experiences both on co-op and here on campus. But more importantly, she told me that she was going to graduate debt-free. And that was an eye-opener for me. That was the first time I'd ever heard that from a college student, and so that's when I knew that I was sold. So really from there, as soon as I came to Kettering, I knew that that was going to be my goal. I wanted to graduate debt-free. And I did that through a variety of ways. First, of course, the co-op experience was a tremendous help, but I even looked at ways to work here on campus. So I was a federal work study student. I worked in a variety of organizations, and that not only gave me the extra funds, but also different opportunities to meet people and understand our resources here at Kettering. Also looking at scholarships not only here at Kettering University, but even from my hometown and other sources, all of this cumulatively helped me to graduate debt-free.
And if you're interested in learning a little bit more about Kettering University, head on over to kettering.edu/apply to learn how you can get involved. Once again, giving away from Gobilda, the Dark Matter t-shirt is going to be a quick drawing for this one. Dark Matter was the keyword for this, and the winner is going to be Matthew 3. Congratulations, Matthew. make sure you shoot me a message so we can get that out. And thanks to Go Builda for the awesome giveaway. We got another one coming up ahead. And of course, we're giving away some Go Builda stuff to our first, second, and third place finishers. Let's send it back over to Alex and the judges to learn more about our number 10 team.
All right. Thank you, Tyler. Going into our 10th ranked team, we have team 5111, Free Gluten, designed by Magnus from FRC 6800. Now, this robot was a lot different from a lot of the other submissions we had in that it had a very high ground clearance, and this was made clear as it targeted the mid climb. The mid climber was a huge plus to see, as we didn't see any other teams really approach this mid climb. It was a solid robot all around, with very well built and sturdy drivetrain, with a paneled construction, and everything was deemed to be mostly functional, if not fully functional, with this robot. We really liked the huge extension that made use of maximum reach into the paywall area, and we would have liked to see more actual renders with this robot. But overall, it was really cool to see this robot, and we thought that everything was generally a good design. We were a bit suspicious about the power transmission from the two motors to the flywheel, as the second motor had very little belt contact. We loved that this robot really took off and executed at all components of the game, and made sure of climbing at mid to play really well support for gaining that HAB RP. All right. And moving on to our 9th ranked team, we have team 9408, Ball, designed by Sivan, Andrew, and John, a ViperBot alumni team.
We really like this robot as well, as it also features an extending intake, which can hold all three balls, allowing for more efficient cycling, as well as a flywheel shooter in order to shoot into all the goals. However, we felt that if it was a robot more so built around its own drivetrain, and it really is, and it's over 12 inches in height, meaning it can't really drive under the payload wall, which would have limited cycling ability. Overall, though, we think it's a nice looking robot, and the renders are pretty high quality for the submissions here.
Mm-hmm. We would have liked to see a little more range with the intake as well, as we thought that reaching deep into the paywall would be more competitive for other teams, especially as balls drain out through match play. But we really like the well constructed intake, and would have liked to see a more consistent shooter mechanism as well, as we thought that the feeder was not fully reliable and would lack some control if placed into reality. All right. With that said, we're moving on to our 8th ranked team, Team 368, Unhandled Exception, designed by Ishan from FTC 18619 and FRC 179.
Now, this team had a really interesting robot in that they sat themselves on the HAB climb, and they didn't have a drivetrain on their robot, simply extending their intake out in order to collect the ski balls and then shooting them into the goals. They had a really nice press release that walked us through sort of how they designed around sort of pressing the rules as far as they could while staying within them. Some things that we really liked were just their overall design and how unique it was. They had top tier strategy, and they did a lot of analysis in order to figure out what they thought the best way to score was without wasting a lot of time with their aiming, and just scoring into the medium point goals rather than going for the riskier high point goals. Something that we would have liked to see on their robot or in their press release was a little bit of math possibly on how they were going to handle the torque from their 66-inch extension on the tubes, carrying the weight of the own mechanism along with the balls that would be flying through. And there were a few limitations with their lack of drivetrain, such as only being able to pick up into a straight line, and also the fact that they had these forks sticking to the underside of the HAB, which other teams might not be designing around, as they feel like they have that 12-inch clearance to go under the HAB, but those forks bring it down by an inch, so they could have issues with running into other robots, as well as the fact that a robot could simply hit them and misalign their robot, which could cause issues with their shooting.
Additionally, we felt that this robot had some of the best renders we've seen, and was also incredibly unique in its overall construction with a lot of bent plates, which is uncommon to see on a lot of robots.
Yeah, we really like the bent sheet construction, and the design really took off and made use of it, especially with that hopper mechanism being designed in just a single sheet. But overall, we thought that the biggest disadvantage for this robot was the lack of a drivetrain, and made it lose some of its competitive advantage compared to other robots in the competition. All right. And with that being said, we're going to move on to our 6th ranked team, Team 2222, designed by Ishwar and Abigail from FTC Team 7244 and 7026.
1-7.
Wrong
Oh.
team.
My fault. Team ranked number 7, 8108, Theoretically Impossible, designed by Arash from FTC 8109. Okay. We really like this robot in that in their press release, they included a section dedicated towards ice rink testing, where they brought out Go Builder wheels and tested the traction and normal forces found when rolling onto a low friction surface like ice. Uh, we thought that the technical analysis provided and the physics that were understood with the coefficient of friction testing made it clear that this team knew what was going to happen with this game. The team had a very clear and high level of engineering understanding all around, taking physics concepts and applying them into the design to create a robot that would perform and could definitely work if it were taken past the design phase. We really like the clean aesthetic with the black and gold, and the very low riding height, which would have made for a very low center of gravity as well.
Yeah, something else is that we really liked was their extending intake. A lot of teams have one of these, but this one looked like it would work really well, as it has a nice long extension. Although the arms do look like they could use a little reinforcement, along with a little more attention to shaft retention and a little attention to detail in other places. But their full field renders were also very nice because you could see the size of different components in relation to the field, and also they had shot arcs on some of their renders.
Yeah, we really like the render quality and all the inclusive renders of active states, and with the full field too. It was really cool to see all this come into play. And we thought that this was a very good and well executed submission. Now moving on to our 6th ranked team, we have Team 2222, designed by Ishwar and Abigail from FTC Team 7244 and 7026.
After witnessing the bending of the rules whenever 22222 competed in the Logic Coyote Tech CAD Challenge, we expected nothing less from them in this competition, and they delivered. They have a robot that literally clamps onto the hab structure before the match using electric screwdrivers, with huge innovation points to be had. They mathematically calculated the trajectory of their shots, showing that even in a worst case scenario, they would still sink the shots almost 80% of the time, if I remember the math correctly. They additionally have an extending intake to intake into the field, and and overall just a really interesting design using mostly COTS parts to do unimaginable things with them, just pushing the limits. One thing we didn't really like, is that their intake was controlled by a string drop down, which we felt would have introduced a bit of swinging, which would make intaking less reliable, as well as the aesthetics not really being there as much as other robots. However, the renders are still very nice, showing a lot of different arcs into the actual field, into the shotting.
Yeah, adding on to that, we thought that this design really took off and maximized every single part of the rules and bended to the rules to every single extent, reaching to the max in both directions. But we thought that this design uh, failed to meet one big thing with the controllability of that intake dropdown. We thought that the string dropdown wouldn't be as reliable as, say, a linear slide mechanism, and with fast turreting and extension times that were shown to us in their press release, we thought that this would cause too much uncontrollability and really draw back cycle times. But overall, we thought that this robot was very innovative in its design, and they clearly took into account the huge load case with having to linear rack their entire robot over the edge of the hab structure. Now we will be moving on to our 5th ranked team, and starting into the top 5, we have Team 667, Strictly Mediocre, designed by VexU student Nat Crawford.
Yeah, so with this team, some of the things that we really liked about them were that they outlined their game analysis and the design requirements based on those very clearly in the press release. When you first look at the robot, not that it doesn't look special, like the aesthetic is really clean, it's very compact, and it looks like it's very low to the ground. There's not immediately anything that stands out. But when you look a little bit deeper, you can see that everything is designed for manufacturability. And this robot, you could take this design and you could build it in the real world. And something else that was really cool was that the load case in order to lift the robot onto the hab was calculated very well here. Something that we would have liked to see improved on was the width of their intake. The intake did extend into the area where the ski balls were held, like a lot of teams did, but the intake wasn't very wide, so it would require some repositioning if there are areas that don't have a lot of balls, or if you're trying to pick up a specific color of balls. And then something else was that this robot was super competitive, but didn't get a ton of innovation points, as it looked like a lot of the other robots we saw, and there weren't any super unique rule-bending innovations that we saw here. But overall, a very nice, clean robot that had great manufacturability. This could have been built a day later.
Yeah, with adding on to that, we really thought that this design was super competitive and very sleek as well. We thought that the huge width tread would have been very traction heavy and would have allowed for a lot of control onto the field. But we did notice a couple of issues with the intake, namely being the servo location for the intake sweeper. We found that the sweeper would run into the servos on the intake and would cause a lot of unnecessary current draw with physical resistance on it. But overall, we thought that this was a very competitive design. We loved seeing the hook shape hab climber implemented as well. Moving on to our 4th ranked team, we now have Team 777 Stasis, designed by Atul. Now, coming into this robot, this is definitely one of the most daunting and honestly cool robots that we've ever seen, and really puts other robots to shame. But the whole design and aesthetic of this robot is really just taken to the next level. Pocketing is everywhere. If not, it's for center of gravity purposes. But we liked every component of this robot pretty much. There was multiple power takeoff systems, very clean aesthetic, minimal errors with the design as a whole, and there's a 12-wheel suspension tank, if I recall correctly, which we thought would have been very competitive on the low traction field. This robot clearly took into account every bit of the game when coming into its strategy. It's very clear with this, as well as very well documented in their press release, which we gave them very high scores on. It's unfortunate that this robot was submitted a little late, as it did receive quite a bit of penalty points, but this robot was very cool all around. We loved seeing a 4-bar hab climb as well. And the insanely high level of detail went into the press release. Very little was missed out on this robot. This robot competed in every single fashion. It played all elements of the game well, and we thought it executed in every single manner possible.
It also just took us an insane amount of time just to wrap our head around that robot, with just how efficient, how amazingly it's manufactured and programmed. Because this could be manufactured as well. It'd be a little daunting, but it could be manufactured and built, which was just incredible for robot design here.
Now, with that being said, though, there was a couple things that we did spot with this robot design that would have made us a little wary of this being actually produced, and that was mainly with the ball transfer from the feeder mechanism into the turret, which we thought there would be a loss of contact from that feeder wheel into the turret structure, into its flywheel, and we thought that loss of contact would be very detrimental towards the design. But overall, we love the amount of controllability that this turret had as well, with an adjustable hood, turret rotation, and internal motor flywheel. All right. And so before we move on to our top 3 teams, our top 3 teams will all be taking home prizes thanks to GoBuilda. And we're going to have to take another moment to bring on our producer, Tyler, to start another giveaway and talk about Fund's other sponsor.
Hey, thanks, Alex. Yeah, we're going to start that other giveaway from Go Builda. That's available to anybody who's watching live right now. That's going to be for a Go Builda blackout hat. This thing's awesome, by the way. So if you're interested in winning a Go Builda blackout hat, all you got to do is type blackout in chat. Right now, we're going to draw for it right after our ad plays on here. But if you do win, please let me know if you want a small, medium, or large, or XL. And like anything else, if you do win something, we need your first name, last name, mailing address, and all that fun stuff as well. So shoot me a DM for that. Here's a little more from our other sponsor on here, which is going to be the Milwaukee School of Engineering, who, if you're interested, is going to be starting enrollment very soon. Fantastic college. Check them out. Here's a little more about them.
What if you could work side by side with the leader in your field from day one? Can a city be both big and small, where you'll find opportunity and community in the same place? What if hands-on learning today led to real-world application tomorrow? What if next-generation technology brought your ideas to life? What if the people who push you forward are also the ones to pull you up? And can the next 4 years get you ready to take on the next 40? MSOE. Rethink what's possible.
And thanks again to MSOE for keeping fun loud, live, and independent. Of course, thanks to all of you for your follows, subscriptions, and bits. It really does mean a lot. Let's go ahead and draw for that giveaway from our friends at Go Builda for the blackout hat. Blackout was the keyword in that as well. And the winner of that is going to be Adi Donkey. Congratulations. Please make sure you reach out to Tyler on Discord. That's me with your information, or you can shoot me a DM on Twitch as well, too. And thanks again to Go Builda for the awesome giveaway. And just like was said by Alex, these top 3 teams are all going to be getting something from Go Builda as well, too. So thanks a lot for that. And we'll send it back over to Alex and team to talk about these top 3 incredible teams.
All right, thank you for that. And before we get into our rankings, our third place team will be receiving a Steel Viper slide kit, also thanks to Go Builda. All right, and with that being said, our third ranked team is Team 987 Looney Squad, designed by Jules and Jameson from FTC Team 10355.
We give huge props, first of all, to this team for being the only team to attempt a buddy climb using a fork to a deep space style fork to lift themselves onto the hab, and using that exact same fork to pick up another robot, allowing them to have a huge competitive bonus during the end game period of the match. Additionally, this robot also had extremely unique scoring mechanisms, being one of the few robots to forego extensive extendo intakes and instead use a butter try design for the drivetrain, allowing them to drive over the barrier, or not barrier, drive over the paywall with ease and just be able to enter to intake whatever they need to in order to score. Additionally, instead of shooting upwards directly into the goals, they actually did play the game objective of skee ball by shooting balls into the ramp in order so that they would gain velocity from the ramp in order to land in one of the goals, which is just incredibly cool to see. Additionally, they use power takeoff modules on their drivetrain as well, which I'm assuming also drives their lift, allowing them to have maximize the efficiency of all 8 of their motors.
Yeah, overall, we thought this robot was unique and just this drivetrain has pretty much never been seen before. We thought that this weird but highly innovative butter tree drivetrain, as they like to call it, would be absolutely perfect for climbing over that paywall barrier, and really supported their strategy. And it was very evident that they had a well thought out strategy with this, as put together in the press release.
Yeah. This robot was just insanely innovative. They had a lot of unique mechanisms, including that buddy climb that nobody else in this challenge tried, and it was all extremely well executed. I mean, you can even just see the amount of pocketing they did. It's clear that they spent a lot of time on a super innovative robot.
Yeah, innovation is just like one of the key point features of this entire robot design. There's differentials, spur differentials inside their drivetrain. Just everything was taken to the extreme, and it's made evident with this robot design.
Not even mention just some of the cleanest renders we've seen. On some of the 3D printed parts, you can even see the layer lines.
Yeah, we really like that level of detail with uh, providing layer lines on the 3D prints and even the belt teeth. All the fasteners were there where we needed it, and it's clear that this robot took an insane level of detail into account with its entire design. Huge props to 987 Looney Squad. All right. And for our second place team, they will be receiving a $25 Go Build a credit card. And starting off for our second ranked team, Team 789, Super Muffin 100, designed by Kellen, Grant, and Tony from FTC Team 479.
Yeah, so this team had a really awesome robot. Their entire robot was really clean. I love the aesthetic, and they demonstrated a really great understanding of manufacturing with their use of sheet stock throughout the robot, as well as pocketing. And it looks like the robot, despite the insane pocketing they've got going on, it looks very structurally sound. And their turret is very well designed. They've got software control throughout. You can see that in their intake and transfer, they even have a hard stop. They've got like a fail safe in order to keep the balls inside their intake. Their entire ball path is really well thought out from the intake to their transfer and then all the way up to their shooter. They've even got a feeder with a color sensor in order to determine what color the ball is. It's overall a very well-designed robot. Some other stuff that we really liked was that you could really see that they had a good understanding of what the meta in this game was going to be, and their robot would have an insanely high level of competitiveness. The one thing we were a little concerned about was their traction, as we weren't entirely sure how well their drivetrain would hold up on the surface, as it is going to be insanely slippery. But their software control with all the turret and hood adjustments, along with that color sensor, you can tell that these people this team really thought out their robot from hardware to software. They've got everything going for them. Their renders were really high quality. Their press release was a little bit on the bland side, but it had all the information that we needed, and it was really easy to understand what their robot was supposed to do, how it was supposed to work, and how they got to all the decisions they made. Like they walked us through what they thought when they saw the game manual, and then the issues that they'd come up with, and then what they'd done to solve those issues. It was very well done.
One thing we were a little disappointed about is the lack of any sort of end game system. This robot did not really think through end game. They didn't really think through end game, and there's not really a climb mechanism, which we felt would have added even more to this already amazing robot.
Yeah, it was a little unfortunate that we didn't get an endgame mechanism, but I think they made up for it, making definitely one of the most competitive and meta understanding robots on the field. The turret, like we said earlier, is very, very well designed, like with a dual servo turret articulation, as well as linear servo adjustment for their hood, and a webcam on top of it to make sure that they understood that controllability was important. There's encoders for its turret rotation. We have color sensors on its feeder, like Luke mentioned earlier. So we thought we definitely understood how this robot was going to work with all its controllability, and for that reason, we thought that this robot would work in an actual sense. And the whole thing is just built like an FRC robot style, like a rapid react. Like this thing clearly understands everything that's going on, and huge props to Super Muffin 100 for creating a very well executed robot. All right, and that's all we're gonna have for our second place team. And our first place team will be receiving $25 in Go Build a credit, as well as a Steel Viper slide. And our first place team is Team 5E, designed by Alex Y and Alex S. Now, we had a lot to say about this robot, and we're going to cover it all. And the biggest thing with this robot was its insane level of detail with the press release and overall robot quality. No steps were skipped in this entire robot production process. It's very clear that this team full well knew what they were doing coming into this design, and they had an outstanding press release to support and describe every detail for it. The press release, they covered cycle times. They cover pretty much everything that we needed to know in the robot, and they even bolded colors for us, so we wouldn't miss out. Like, this thing would be top tier in an actual sense for its insane high level of quality and detail. It's clear that this robot would actually work. We really loved and gave huge innovate points for its top rollers, which we thought would have gave this robot the biggest competitive edge on the field out of anybody. The top rollers, as seen by the green rollers on the top of the robot, are actually geared together with the drivetrain, and these work in the opposite direction. So as the robot travels through the underpass, the top rollers would be able to gain traction on uh, the high traction HDPE material on the hab structure. And so them getting an additional traction boost would allow them to really just switch directions fast and also gain a little extra boost as they travel under the barrier or under the hab structure. Uh, but with that being said, we did see a little bit of issues and very minor at best. Uh, we noticed that the rotation for the hab climber was with little cutout triangles, which we didn't think would handle the load case very well and could potentially strip out if an entire robot weight were to be held on to that. Luke, do you have any notes for this robot?
Yeah, I mean, my favorite part about this robot was definitely the roof wheels. All these teams were looking at the drivetrain and what material they could use on it so that they wouldn't be slipping around on the surface of the field. And I mean, obviously, this team did that. Team E they covered all their bases. But in addition, they have those roof wheels, so they're going to be able to stop themselves if they need to shoot. They're going to be able to quickly start and stop when they're moving back and forth from shooting and collecting. It just gives them like that next level of maneuverability that no other team had. It just gives them that insane step up in the competitiveness of their robot. And something else that I really liked was on their climber. I know that we were concerned about the load of those little squares, those little triangles. I mean, but I loved their renders where they had both robots sitting up there. It was two of the same robot. Like, it must have taken an insane amount of time to render these things, and they've got calculations for their climbing torque. They've got specs for all of their systems. They detail the rigging of their intake, and they've got everything. They covered all their bases, and that to me is what really sets this team above every other team in the competition.
Additionally, they have one of the more unique strategies as well. Like, being able to just sit under that hab structure and just intake and shoot means that they will lose traction a lot less and be a lot less prone to defense. And they also went for the actual skee ball shooting route instead of trying to shoot directly into the goals, which was really nice to see.
Yeah, we thought the turret mechanism for their ski ramp shots was very unique, with the offhand turret rotation, with where the entire turret is actually rotating around its feeding center, and it rotates along that point, and there's a motor for its turret rotation that's on the turret rather than being away from it and stationary, which we thought was really cool. And they included a camera as well, and it's very clear that this robot understood the software controllability that an actual software team would need if this robot were taken into reality.
Yeah, you can really see in their autonomous, they have detailed out every single step that they're going to take, how they can maximize every little second down to the millisecond of how long each step is going to take. They're giving themselves buffers so that they can descend in this amount of time, but if it doesn't work, they've got a little bit of a buffer. You know, they really have everything detailed out down to their cycle time being broken down into how long they're spending doing each step, how long it's going to take them to pick up a cargo, how long it takes to drive to where they're going to shoot. They've really got everything figured out.
Yeah, for sure. This team left no stone unturned in this entire design process. And the press release is really just a benchmark for the level of technical detail we got in the press release pages, going down into each subsystem. Like, even if you had never seen the robot before, if they left all the pictures blank, I could get a very good understanding of what this entire robot was. And just the whole thing has an insane level of detail. Every screw, like every nut, is in there. It's very clear that this robot was the top contender for sure. All right. Well, congratulations congratulations to Team 5 and to all the teams that provided submissions for this year's Valor CAD Challenge. Thank you to all of our judges who worked hard to rank these teams, and make sure you stay in the Valor CAD Challenge Discord for our next event. And thank you to First Updates Now for producing our awards ceremony. We really couldn't have done it without them. Thanks for everyone, and see you next time.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support first teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today. If you want to continue enjoying the excitement of robotics, come check out what's going on at Kettering University, including their Combat BattleBots team and First Center. Turn your robotics experience into a professional career. Be sure to apply to Kettering beginning in August of 2022. Go to kettering.edu/apply to learn more. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.